To get started in this course, you should have a fair understanding of Amazon Web Services and the different use cases for the services, such as S3, Glacier, and EBS are great storage options, computing services using EC2, and RDS for databases. If you're brand new to cloud computing, I highly recommend that you take an introductory to AWS course. If you feel comfortable, let's go ahead and dive in. The AWS Cloud Adoption Framework helps organizations understand how cloud adoption will transform the way they work. It provides structure to identify and address gaps in skills and processes. By applying the AWS Cloud Adoption Framework in your org, you will help create an actionable plan that can guide your organization's path to the cloud. The CAF considers 6 stakeholders' perspectives when migrating to the cloud. This framework outlines the key concerns of each stakeholder and what they need to understand to move forward. Business stakeholders' perspective revolves around business basics. How the benefits of migration measured? What are the opportunity costs and how will that affect business goals? They may even consider how will the billing, mapping of the services, and analyzing the benefits against the costs be measured. The people's perspective is mainly driven by HR managers and staffing individuals whose main focus is ensuring your company has the personnel with the skill sets to migrate to the cloud. It is up to these individuals to ensure that your employees are given enough time to learn AWS by reading professional papers, attending conferences, or watching online video content. Your CIO, program manager, or project managers are interested in governance. This involves them understanding how to manage the investment and measure the investment outcome when migrating to the cloud. It's also important to understand how new agile cloud technologies can be implemented in new or existing projects. Now let's start taking a look at the 3 more technical perspectives, starting with platform perspective. This involves the individuals at your companies understanding how to directly implement cloud infrastructure. The individuals in your organization that are required to deploy the services will be concerned about which AWS service to provision and how to migrate on-premise services into the cloud. This includes computing, database, or storage services, while also understanding how you can make your IT infrastructure fault-tolerant and elastic to meet your company's fluctuating needs. Security is always a concern, no matter if you are on-premise or in the cloud. The security perspective mainly comes from the CISO, security managers, or any IT security analyst in your company. As always, these individuals are looking to ensure your organization's cloud infrastructure has security in mind. They will be looking for the guardrails to ensure control of authentication, access management, encryption, ensuring the principle of least privilege. And if a security incident does occur, how will it be handled? Once your services have been deployed, it is now up to operations to keep it running. It's operation managers who will have the operation perspective, looking at how they can carry on to support and detect and respond to any IT service or application incidents. This would be a good time to look at the various monitoring and managing services AWS offers, such as CloudWatch and System Manager. Once you have identified the stakeholders for each of the 6 Cloud Adoption Framework perspectives, you're ready to review and document issues in your company's existing skills and processes. At this point, these issues can be recorded as inputs. The inputs can then be used to create a cloud adoption action plan. AWS provides this sample action worksheet to help you get started. At this point, you should have documented the 6 perspectives. Now you will continue into what are your strengths and weaknesses. This will assist in creating action plans to fill in any gaps. This is known as a Migration Readiness Assessment, or MRA. One of the main reasons to complete the readiness assessment is to determine what stage your organization is currently in. For example, if you are in the early project stage, you should consider preparing for larger migration initiatives. This would involve laying the foundation for future migrations, such as proper tagging or a configured identity access management system. The main outcome of the readiness assessment is identifying strengths and weaknesses for adoption in your organization. A strength would be a project that requires no further work to migrate to the cloud, while a weakness would require further work before migrating, such as developer training or infrastructure discovery. First, you want to set up a MRA meeting. Make sure to invite all personnel involved in the migration to build department alignment. It would be good to encourage maximum participation to help build consensus. Identifying actions for each department to help get your organization to a state where they are ready to begin a migration. Try to ensure the first application migrated should go as smoothly as possible. Don't try to solve every single issue that might arise. During the MRA meeting, topics should include reviewing migration motivations, cloud strategies, and building department alignment. The MRA session should have given you a collection of data to use for creating actionable steps for each area in your organization to start migration. With the first migration of an application, do not try to attempt to solve every problem, but instead think of it as an iterative approach. Each action should have a set owner, completion date, and any details for completion. In the next few weeks, set up a follow-up meeting. During this meeting, it's important to deep dive into how to start the migration. There should be a summary of high-level action items with a focus on your organization's observations, objectives, strengths, and weaknesses, and how you can go about resolving any weaknesses that have been uncovered. Once done with the readiness assessment meeting in action, you should have completely identified actions and created a defined plan that will lead you to the mobilize phase of the migration. This phase objective is getting workloads migrated. It would be best to identify the low-risk, easy-to-move applications for early success stories in your company and help create company-wide buy-in and excitement. One part of the MRA outcome that should be worked on is the time frame of each migration sprint and what it entails, which services might be migrated, and the duration of the sprint. To help you get started, you should go ahead and take the Cloud Adoption Readiness Tool Survey. It's a short 16-question online survey that assesses your migration readiness across the 6 perspectives. Once you complete the survey, you can download a customized cloud migration assessment report that charts your readiness and steps to improve before migration. Another very helpful tool to get detailed server and application costs and saving projection is the Migration Evaluator. By either installing a local agent in your environment to collect data or providing the data yourself through an Excel spreadsheet, you can get a team of AWS Solutions specialists to evaluate your estimated migration savings. The next step is to mobilize. This requires you to prepare your personnel and resources for migration. The mobilize phase activities can be broken down into these work streams. The best business care objective will align stakeholders and executives. It's a business case that includes objectives and outcomes such as cost and savings, business benefits, time for migration, and which workloads will be migrated. A vital part of the migration strategy is the collection and application of portfolio data to build alignment. This discovery of data will allow you to plan migration waves, find interdependencies, and understand the infrastructure complexity involved in the migration. Ultimately, you want to create a schedule for migration. The migration governance workstream involves management of scope, scheduling resources, planning, and risk assessment, as well as communication for any workloads to migrate. The ultimate goal is to create an agile program that includes consideration for implementation plans for complex workloads. The landing zone workstream is meant to develop the foundation to your AWS environment. The objective is to create an AWS initial account configuration that includes multi-account structure, networking structure, identity and access management, as well as billing. The security, risk, and compliance workstream is meant to help build confidence in your AWS infrastructure. By outlining the desired IT service management states, operational practices, potential security issues, as well as business continuity planning, and how your migration factory will impact traditional operations can help build confidence. The purpose of the operation workstream is to review your current operational model and integrate your future cloud adoption. Operational models should include any processes, tools, or individuals to meet the IT objective. Begin by creating a roadmap that identifies your IT services, the desired state, operational practices, potential vulnerabilities, and the business continuity plan on ground and cloud infrastructure. You and your coworkers are a very critical part of the migration readiness process. The changes cloud migration brings can be felt throughout your organization. There should be an established strategy to ensure organizational-wide communication patterns, employee training, and support. The objective of the people workstream includes designing and training the teams responsible for critical cloud migration, which they can then set standards for future migration workloads. Application migration workstream uses the other workstreams. It requires that you migrate a workload to really understand migration challenges, tools, and processes. By doing this, it will provide you some hands-on understanding of the best practices to migrate an application, validate your AWS landing zone, understand your security and operations playbook, and help train personnel. Go to the AWS Control Tower service in your AWS account to set up a landing zone for your organization. This will create a multi-account AWS environment that has AWS best practices built in, as well as security guardrails. The Application Discovery Service is a useful tool provided by AWS to automate the discovery of applications and server inventory, as well as resource consumption characteristics. This tool can be used to build out a real-time model of your application and servers, as well as their dependencies. The goal of the migration plan is to lead the migration efforts at a high level. This includes managing the scope, the scheduling, resource planning, and any issues that might come up, as well as the communication between teams. The migration plan considers critical factors such as the order in which workloads should be migrated, tracking the progress, and when resources are required. The migration plan activities generally include project management methods, determining which migration tool to use, how will the teams communicate with one another, any risk assessment, as well as roles and responsibilities, and the outlining of the timeline and cost. Part of the technical planning aspect of the migration plan is setting up a small team to complete deep analysis and prioritize the application portfolio, thereby building out a backlog of 2 to 3 weeks of migration sprints. The next step as part of the technical planning aspects is to develop an AWS architecture and begin the migration of the prioritized applications. From this point, you should start seeing patterns in the applications you migrate. Grouping applications that have a similar pattern for migration can help optimize the process. Once you start your first migration, you'll be able to build hands-on experience. It should hopefully allow you to identify common application migration patterns that later on will help you migrate 3 to 5 applications with common patterns, creating migration waves that can be done by sprint teams in parallel. The execution phase of the migration should follow these steps: discover, design, build, integrate, validate, and cut over. The discovery stage uses the application portfolio data to understand the cloud architecture needed for migration. Things like cutover plans, server performance, networking requirements, data flow. The application owner and the sprint team in charge of the migration should consult one another during this stage. It's at the design stage that the data collected during the discovery stage is used to design out the application and its targeted AWS environment. This should be documented, specifically including data such as monitoring and external resources used. During the build stage, the migration design created during the design stage is implemented. All the requirements for the migration are assembled at the build stage, including any tools, individuals, or templates, and the migration to AWS is then executed. Depending on the application, there might be external services or resources required for the application to work correctly. During the integration stage, your migration team should make these external connections. Before the migration can be finalized and entered into the cutover stage, your application should go through a series of specific tests. These tests can include a build verification, performance, disaster recovery, or any business continuity testing. It is also advised to create a rollback plan and finally test the pre-migrated and the migrated application in parallel. The cutover stage allows you to execute the cutover plan, in which case the newly migrated service will take over. If the user test fails, you should implement the pre-planned rollback procedure. To help accelerate the migration process, a migration factory should be established. This would be your core cloud team, individuals who mainly work on the migration, focusing on repeated migration patterns and release management plans. The monolith is a legacy application where all services and components are on a single server. There are serious limitation issues that come along with the monolith, such as hardware limitations, cost of provisioning hardware, as well as deployment restrictions. When working in a cloud environment, there is the concept of running a cloud-native application. The definition of what cloud-native means can vary, but the idea is taking advantage of the scalability, flexibility, and the cost of building out a more dynamic environment in the cloud that takes advantage of using containers, microservices, service mesh, and container orchestration platforms. When working towards a cloud-native environment, you'll have to develop a new mindset on how to design and deliver your services and applications. There will be a learning curve to this new mindset of cloud-native approach, but your company will be able to bring new ideas to market faster and respond faster to your customers' demands with the cloud-native approach. By taking advantage of service-oriented architecture, you'll be able to loosely couple microservices together. This will allow for greater experimentation and reliability. Containers, which are standalone, can enable you to isolate microservices and deploy them independently. Cloud-native technologies generally include containers and Kubernetes. These technologies do pose a learning curve. Deploying these technologies does require your time to deploy, configure, and maintain. When using the service provided in AWS, you can quickly start running these technologies with minimal effort. If you decide to switch an application to a cloud-native design, you want to identify the benefit for choosing this strategy. You'll also want to identify how this will change your company's operating model. By going cloud-native does not remove all security concerns. The reality is running in a cloud environment can reduce your risk It does not eliminate it. You should understand your responsibility in the shared responsibility model that you agree to when you go into the cloud. The cloud-native path initially begins with selecting an application to refactor. This means to select an application to be containerized. Leveraging containerization, you can decompose your application into microservices running within containers. By applying DevOps methodology, you can apply a CI/CD process that would streamline your deployment pipeline. Once completing your initial migration, you're going to want to go back and update your business plan and refine your return on investment. You will also want to review your cloud adoption framework perspectives and ensure that each perspective has been met as part of the migration. If the perspective has not been met, then you're going to want to update the perspective and review your migration. Optimization is an important aspect of the post-migration stage. You're going to want to ensure that you optimize cost, scalability, utilization, elasticity in your environments. To do this, you should closely monitor your environments. There are many tools to help you do this. Such tools include AWS CloudWatch, SolarWinds Server and Application Monitor, Datadog AWS Monitoring, App Dynamics, and more. Once you build up your experience from your initial migrations, you'll notice that your migration process will accelerate. You'll now be able to tackle the backlog of workloads you plan to migrate. After your initial migration, you will find that you're building confidence in your ability to migrate to AWS. You will learn from your hands-on experience, and you'll be able to tackle those future migrations faster and with each iteration improve the migration process. The 6R framework is a guide to help you categorize the migration options for the applications in your environment. By determining which of the 6 strategies your application might fall in will assist you in understanding the time, effort, and cost of migration. The complexity of the migration depends on such things as the application architecture, existing licensing agreement, and business requirements. When selecting your migration path, you're going to want to prioritize business functionality, followed by application optimization. Taking these factors into consideration, you should then determine which migration path is best for any specific application. You might choose to retire a service or rehost the service, and we'll go into detail on what this means in the coming slides. One of the most common migration strategies is known as lift and shift, or to rehost. This essentially means taking an existing application or service and moving it exactly as is into the AWS Cloud environment. A lift and shift is an excellent solution for quick migration. The replatform strategy, also known as lift, tinker, and shift, will allow you to take advantage of both a quick migration while utilizing cloud optimization features and achieve a tangible benefits. For example, managing a database server can be very time-consuming, but as part of your replatform migration strategy, you can quickly migrate to a managed database service like Amazon RDS. The most involved but beneficial migration strategy is to refactor or re-architect your application. This involves you reimagining your application architecture to be more cloud native. For example, you can take a legacy monolith application in your data center and refactor it to use service-oriented architecture to improve your business continuity. The repurchase migration option involves leaving a perpetual license and moving to a software as a service model. For example, you might choose to move your current customer relationship management software to Salesforce, or maybe you want to move to a content management system such as WordPress. It's estimated 10 to 20% of IT infrastructure is no longer in use and can be decommissioned. Quickly identifying which applications can be retired will help boost your migration business case and allow your migration team to focus on more important applications to your business. The retain strategy allows you to keep critical applications as is. This is commonly done when the migration will take significant refactoring. You should come back at a later time to reevaluate these applications for migration when time is permitted. When selecting the correct migration strategy for your company, you want to take into consideration the time it takes to migrate, business demands, financial limitations, and resource requirements. For example, if your data center lease is going to expire within a few months, you might choose to rehost the majority of your applications. Then at a later time, refactor them to take advantage of cloud-native architecture. Whereas if you have significant time, you might choose to refactor immediately during the initial migration cycle. There are some challenges and limitations when you're rehosting or lift and shift an application. A lift and shift is moving an application or system exactly as is into the cloud. This migration strategy will, in the majority of cases, be your first approach to migration because it's easier and faster than any other approach. Then once it's in the cloud, you can later optimize or re-architect the application. It's interesting to note that often doing a simple lift and shift into AWS without any optimization can save up to 30% of the cost of running that same workload in your on-premise data center. The rehosting strategy is really well suited for large-scale migrations where your company wants to meet business objectives very quickly. Once the application is running in the cloud, you can then proceed to optimize your application. By rehosting first, it's generally easier to optimize or re-architect your application to be more cloud native. The whole process of rehosting can be automated using some of the migration tools available, such as AWS Application Migration Service, which was formerly known as Cloud Endure Migration. An example of rehosting can be seen when you're running an on-premise MySQL database server. But instead of migrating that to a managed service like AWS RDS, you choose to migrate it to Amazon EC2 instance, which will require absolutely no changes to this database or how the database is running. Some of the obvious pros to the rehosting migration strategy is obviously the speed of migration and a reduced risk of configuration issues. But the con is not taking advantage of any managed services to reduce your workload. The second main issue to consider is inheriting issues that existed before the migration. Replatform, also known as lift, tinker, and shift, is the process of moving an application to the cloud while at the same time introducing some level of optimization to take advantage of the cloud capabilities. Say you want to migrate an application to AWS without changing the core architecture of the application, and part of the migration includes an Oracle database. A replatforming option would be to take advantage of AWS RDS managed database service to replace the Oracle database and then only being required to change the database endpoint in the application, which wouldn't change the core of your application. The replatform strategy is also helpful if you have a time-sensitive migration that cannot be fully re-architected, but still want to take advantage of some of the cloud services. Replatform can also be helpful if your workload needs to be resilient by creating some redundancy using cloud-native improvements, or if you have an application that has reached EOS. Some of the benefits of replatforming includes automating in-place OS upgrades with AWS System Manager, as well as creating private VPC subnets to isolate workloads of outdated operating systems. You can also quickly replicate production environments for testing. The initial step in a replatforming strategy is to rehost your workload. Once you have your workload in the cloud, you can begin to replatform in AWS and start taking advantage of some of the cloud services. Using AWS services for this strategy includes AWS Application Migration Service and AWS Server Migration Service. Replatforming can decrease your security risk for any legacy application running on unsupported operating systems. It also reduces costs and can improve the overall resilience and transparency by using services such as AWS CloudWatch and System Manager. When replatforming a database, there are a few options. If your commercial off-the-shelf application does not support an open-source database, there is the option of using Amazon RDS for Oracle or Microsoft SQL Server. For any in-house application, you can reduce your database licensing costs and increase scalability by replatforming to Amazon RDS for PostgreSQL or Amazon RDS for MySQL, as well as DynamoDB or Aurora. To help with database migrations, there are AWS services to help automate the schema conversion process known as AWS Schema Conversion Tool. Then for database replication assistance from on-premise databases, there is the AWS Database Migration Service. To re-platform any file sharing service, you should consider modifying your application to use Amazon S3 and CloudFront for high availability and durability of your data with support for NFS and SMB. If block-level services are required, then using tools like DataSync and Amazon Storage Gateway can help you migrate to Amazon EFS for Linux or Amazon FSx for Windows file servers. When platforming legacy applications, it's important to test for functionality and performance. There are tools available to help you automate testing to ensure the full functionality of your application. It's also important to include the application owner in the re-platforming strategy. Refactoring your workload can improve an application's agility, performance, and scalability. Refactoring is the process of modifying your application's architecture during migration to take advantage of cloud-native features. This should allow you to realize the full potential of a cloud design that could include serverless functions, containerization, and load balancing, just to name a few. Some examples of refactoring can include rewriting an application to be serverless and run as a Lambda function, or taking a monolithic application and containerizing it. Re-architecting a legacy application to take advantage of cloud services would make your application cloud native. The lift and shift alternative can be faster, but migrating a workload to the cloud with a lift and shift design can result in bringing your mess with you. Any issues you had on-premise will not be resolved by migrating to the cloud. Some reasons for refactoring can include a workload improvement, for example, to improve the scalability, speed, or performance of your application. It could also be done if there is an incompatibility with your current legacy application and AWS that refactoring has to be done. At some point, the added expense and effort for refactoring an application will be outweighed by the benefits of going cloud native. While there are many advantages to refactoring, there's also a catch. Too much refactoring can be risky. Trying to perfect an application before migration can take years. It's also up to you to find the medium path of minimal viable refactoring. What are the minimum viable refactoring changes that can be done to maximize your cloud migration? What are some high-value, low-cost, low-risk changes that can be done to your workload to maximize the cost versus the effort? During refactoring, use a dev and test environment in AWS to allow you to quickly test these minimum viable refactoring changes. Some applications are more critical to your business than others. Which of your application workloads will give you a tangible return if refactored? Which application will provide the most benefit if refactored by improving maybe customer experience, meet business demands, or allow for new business innovation? The process of refactoring does require a higher level of cloud knowledge on how to adopt some of these technologies, such as serverless or containerization. There will also be a need to implement a DevOps and agile practices to your workloads. Repurchasing, also known as drop and shop, is the process of decommissioning an application and replacing it with a cloud-native software package. This might involve using a software as a service solution or licensing a cloud version of an application. Repurchasing might be the best solution to replace a legacy workload that is incompatible with AWS. Repurchasing can be used to improve functionality. For example, you can replace a custom-built in-house application with a commercial product. A common approach in these cases is to adopt a SaaS solution or move licensing to the cloud. Some common steps for repurchasing are to review your current application and then compare it against what's currently offered as far as SaaS solutions. Determine licensing and any costs that might be associated with it. And check the steps required for replacing and importing the current application data. Then finally, test the solution and purchase the application for your environment. There are many benefits to the repurchasing strategy, such as replacing any legacy outdated workloads with a more modern SaaS platform. This should hopefully increase business efficiency and ultimately cost savings. The risk associated with the repurchasing migration strategy includes retraining of staff on the new platform. There would also be a certain level of vendor lock-in once all the data and services have been migrated to the SaaS platform with limited customization options. And there's always a possibility it's just not compatible with your existing workload. The AWS Marketplace is a huge digital catalog of third-party applications and services that can quickly and easily be provisioned into your AWS environment. With over 10,000 products covering categories like security, business applications, data analytics for industries like healthcare, financial services, or the public sector. It would be beneficial to at least take a look at the offering in the AWS Marketplace for possible repurchasing options that would benefit your company. The first cloud-only bank, TBC Bank, found that migrating legacy on-premise infrastructure to the cloud didn't give them the agile benefit they were looking for. By using a product from the AWS Marketplace, they were able to migrate to the cloud successfully within a matter of months. The cloud migration strategy, retire, is the process of terminating or downsizing any workload that are no longer required in production. It's common for a company to have as much as 10 to 20% of their IT infrastructure that's no longer in use. Possible use cases for the retire strategy includes retiring an application that is redundant or obsolete, applications that provide no business value, even applications that are being retired to bring on a new refactored version. Retiring an application can boost your business case, thereby saving any costs associated with running the obsolete workload. Retiring an application allows your migration team to focus on business-critical workloads. When retiring workloads, you should be especially careful to determine if there are any dependencies. Also note if there's no documentation on the legacy system or if the original developer is no longer with the company. You will also want to be careful that retiring a legacy application doesn't inadvertently postpone the migration process. Depending on the size of your company and the number of workloads to retire, you might find benefit in streamlining this migration strategy using a migration factory approach. This team would capture any dependency data from the application log or network traffic, then analyze the impact of retiring the application before decommissioning the servers. It is beneficial to retire workloads early in the migration process. If left to the end, you run the risk of having minimal time to migrate the application if determined to be vital. There will also be fewer servers to upgrade, patch, and maintain during the migration project. Monitoring and analyzing data is critical. Infrastructure diagrams can be outdated, meaning a workload scheduled to retire can be a dependency for a business-critical application. By collecting any inbound and outbound network traffic information, you can investigate any possible dependencies. Before retiring a workload, you can schedule a control stop to identify any potential disturbances. This can be done by pausing a virtual machine, stopping a service on a host, or blocking all traffic from an external firewall. The length of the control stop can vary based on the application. After monitoring and a control stop, you can now reassess your migration plan. By completing these tests early on in your migration process, you should have time to rehost your application to the cloud. Once you determine an application is safe to retire, you can then begin the retirement process using a migration factory standardization approach your migration team has developed. Before completely decommissioning the application, consider backing up any data. AWS offers long-term cheap storage using AWS Glacier or AWS Glacier Deep Archive. Retaining, also known as revisit, is a migration strategy in which you do nothing, for now. The legacy application remains unchanged and in the current environment. There are many reasons why a workload will remain unchanged. If your company is planning on implementing a hybrid cloud model, maybe your current infrastructure was recently acquired or it's part of an active development project. There could also be a compatibility or compliance issue that would prevent an application to be migrated to the cloud. Maybe it is just not a good time to prioritize this specific application for migration. Your company has scheduled this workload to be depreciated shortly, or you might choose that it's just not worth the effort right now and wait it out. Or maybe this application has latency or performance requirements that cannot be met effectively in the cloud. Or you just decided there's no cost benefit. There are many reasons why to choose this retain migration strategy. Some of the issues associated with the retain option is that it remains unchanged, which means that you are not taking advantage of any possible savings that could be achieved by migrating. There's also the extra operational cost that might remain if retained, plus the fact that you will eventually have to revisit this workload at a later time. A very popular cloud model is the hybrid model. There are many benefits of running concurrent cloud and on-premise infrastructures. This is especially true when an organization needs to run large-scale migrations over several years and they want to ensure business continuity. Then a hybrid approach would most likely be used temporarily or for the long term. Data is used for application workloads, data analytics, machine learning, and more. An application migration would not be successful if the data required was not properly migrated first. When performing data migrations, you should consider how much data do you need to move. If it is a significant amount of data, then do you have the network bandwidth and device throughput to realistically migrate that data over the network? Also consider whether downtime needs to be scheduled and for how long. And are there costs associated with the transfer of this data? Do you know your data profile? For example, how much data do you need to transfer? How many actual files do you plan to transfer? Is it many small files or just a few very large files? What does the data look like? Is it on one location or across many devices? Should your data be transferred online or offline? And most importantly, which application depends on this data? There are different ways to lift and shift data, such as a one-time large batch transfer, constantly streaming the data, intermittently updating the data, or maybe you want to implement a hybrid data storage approach. Some workload considerations that should be considered are what would be the impact of your storage device during migration of your data used in production. How would this affect the performance of any application accessing the data? Can your storage device scale to support the extra load placed on it? You should determine if the metadata such as file ownership, permission, timestamps of creation or modification should be retained during your data migration. Metadata may be helpful for backups, user files, access restrictions, and documenting file access history. When planning a data migration, it's important to understand how long the migration might take and what is the best approach to minimize the time and cost. To help you determine the number of days a network transfer would take, you could use this formula. For example, if you have a T1 connection that has a 1.544 megabit per second with an 80% utilization, you want to transfer 1 terabyte, it would roughly take about 82 days. In most cases, this would not be a practical length of time that you might consider to rather do a offline batch data transfer. Here we could take a look at a timetable of network connections and the amount of data you roughly want to transfer. Then what would be the length of time to complete the data transfer? Clearly the red would not be acceptable length of time, while the yellow would be acceptable, and the gray is acceptable based on the use case of the data. Based on the type of data migration you plan to perform, you can use some of the tools AWS offers, such as AWS Data Sync for live network data transfer, maybe a hybrid cloud approach with AWS Storage Gateway, using Amazon S3 for cheap long-term storage, AWS Snowball family of services for offline large data migration, or for streaming data with Amazon Kinesis, plus Direct Connect for dedicated network connections to your AWS environment to your on-prem data center. Once you're ready for your data migration, you want to test and verify before committing to a migration schedule. You need to verify such things as your source performance, any network bottlenecks, encryption of the data in transit, and an accurate time frame of completion. Once your data has been transferred, you need to verify that your data was migrated successfully. You should test if your migrated data matches the source. This might require that you write or code some verification scripts. This is specifically important for any medical records, financial institutions, or data sets used for analytics. It's not uncommon for an organization to segment their workload into multiple AWS accounts. But it is important that you thoroughly think which AWS account should hold your data and which data exactly, based on the workload that will also run in that same account. The hybrid storage cloud model takes advantage of the benefits of cloud storage while maintaining applications running on-premise. If you want to take advantage of cloud storage, but your application just needs to run on-premise, the hybrid cloud model would be your best bet. The hybrid cloud model reduces some of the operational overhead found on-premise and frees up resources. Using some of the AWS services, you can use your existing on-premise application with AWS storage services with no change to your software application. Services such as Amazon Storage Gateway would allow transparent access to your data in the cloud. Using cloud storage with an almost unlimited amount of storage, you can easily consolidate and manage all your data in a central location. To simplify your adoption of AWS storage, you can use AWS Storage Gateway and AWS Direct Connect. AWS Storage Gateway is a collection of services that gives you a variety of options to integrate your cloud storage with your on-premise workload without rewriting existing applications. Some of the features of AWS Storage Gateway includes Amazon S3 File Gateway that enables you to store and retrieve objects in S3 using NFS or SMB protocols. For Windows servers, you can use Amazon FSx File Gateway that allows you to write directly into Amazon FSx file systems. If you need support for iSCSI for a block-level storage, you can use Volume Gateway, which stores data on Amazon S3 or Amazon EBS. For system backups, you can use iSCSI Virtual Tape Library interface using the Tape Gateway, which includes a virtual media changer, virtual tape drive, and virtual tapes. Then you have the option of storing your backup to S3, Glacier, or Glacier Deep Archive. The benefits of using AWS Storage Gateway to implement a hybrid storage environment is the support of widely used standard protocols such as iSCSI, SMB, and NFS. It also offers local cache for low latency access to recently used data, plus integration to other AWS services such as Amazon S3, CloudWatch, IAM, EFS, and more, plus easy deployment of an agent into your existing environment. The main reason to implement a hybrid storage environment is cost savings. Purchasing network storage can be increasingly expensive to purchase and maintain. By using cloud storage, you would forego the large upfront costs. The hybrid model is also commonly used as a backup solution using Glacier or Glacier Deep Archive for cheap long-term storage. There's also the option of collecting streaming data and storing that in AWS for later. To collect streaming data for machine learning or data analytics for real-time information, you might choose to use Amazon Kinesis. An example use case of Kinesis is collecting sentiment analysis from social media, running it through machine learning, and using that knowledge with an on-premise application for real-time business-critical decision-making. Online data transfer allows customers to copy between an on-premise data center and AWS storage services. This can be done on data actively used in production while the transfer is occurring. Here are some of the online data migration tools. This includes AWS Data Sync, which allows for an online data transfer between an on-premise data center and an AWS storage service, or between AWS storage services. AWS Transfer Family Service provides managed support for common transfer protocols such as FTP, SFTP, and FTPS. While AWS S3 provides object-level storage, one of the features includes S3 Transfer Accelerator, which enables fast, secure transfer over long distances. Amazon S3 provides object-level storage in the cloud and is designed to be highly scalable, highly available, durable, and secure. With basically limitless storage, you can store data lakes, websites, backups, mobile applications, big data for analytics, and more. AWS S3 provides acceleration over the public internet to transfer data to S3 faster. By using Amazon's global distributed edge locations and Amazon CloudFront, it will help maximize the available bandwidth regardless of distance. This is a great feature for global teams. AWS Data Sync helps automate and accelerate the transfer of data between your on-premise data center and AWS, or between AWS storage services. It will attempt to optimize the network connection available. It can be used with AWS Direct Connect or over VPN over the public internet. Data Sync can be used for batch data migration or with recurring data processing workflows, as well as automating replication of data and data recovery. AWS offers unmanaged migration tools such as rsync, which is an open source file system tool for syncing data. The AWS CLI provides Amazon S3 command line interface, as well as their S3 Glacier command line interface to copy directly into an S3 bucket or a Glacier vault. Direct Connect is a dedicated physical connection to accelerate any network transfer between your on-premise data center and AWS. Direct Connect can be an expensive solution, and it does require setup time, but it provides a more reliable data transfer network, and it's ideal for regular large data transfers or a more accelerated network connection to your AWS infrastructure. An alternative to Direct Connect is AWS VPN. It establishes a secure connection between your on-premise network and AWS. It's quick to set up, cost-efficient, and is ideal for small data transfers, but it is not as reliable as a dedicated network connection. Here we have a network diagram of an AWS online cloud migration infrastructure. The on-premise file share or object storage that connects over NFS or SMB to the AWS Data Sync agent that was deployed on either Hyper-V or VMware Hypervisor. From there, a direct connect or an encrypted VPN connection is established. Data Sync should seamlessly connect to the AWS service to copy the data to either S3, EFS, or FSX. To set up AWS Data Sync, you want to log into your AWS account and go to the Data Sync service and click Get Started. The first thing you need to do is create an agent. There are multiple options for agents, such as VMware and Hyper-V. Once you select your agent deployment option, you're going to select the service endpoint. This is how the agent will connect to your AWS account. You can choose VPC if you have a direct connect or VPN connection, or you can make it a public endpoint. Once your agent connects, you're going to click Get Keys to set up your connection between your on-premise data center and AWS. Your agent should be installed near your NFS server. So for this scenario, I have a hypothetical NFS server set up. I want to transfer files from my NFS server to an S3 bucket. I'm going to click on locations to create my source and destination location. My destination, it would be my S3 bucket, and my source is my NFS server. I'm going to select location type, NFS. Now I'm going to provide the agent that I just created, the NFS server domain name or IP address, and the mount path of the files I want to transfer. When I'm ready, I click Create Location. Now I created my source, I just need to create my destination location. Click Create Location. This time I'll select S3. So I have a pre-existing bucket created for this. You can choose the S3 storage class or any folder prefix in the bucket you would like the files to transfer to. I'm just going to put / so it's the root of the bucket. And then I'll go ahead and click Create Location. Now that I have both my source and destination created, now I'm going to create the task. This is what's going to actually copy from the source, which I select first. I'm going to create my task, source location, and now I'm going to select my destination location. So I'm choosing existing location that we just created. Now I'm going to name my task. HR data transfer. Now you get a few options about how to verify the data, setting bandwidth limits, if you want to overwrite files or copy just a subfolder, if you want to schedule the transfer hourly, daily, weekly, and then how would you like it logged. Now once you're ready, you can go ahead and review the content and click Create Task. You can verify the data here, the location and the destination information. And then when you're ready, you can go ahead and click Start. You can start with defaults. And this will go ahead and immediately start the task. You see the status is running. Depending on the amount of files being transferred, the time it takes to complete this task will vary. Once the job has completed, if you click on History, you will see your execution ID number, and the status should change to Successful. And then on the top, the task status should become Available. You can also click on the execution ID for additional details of the transfer. An offline data migration is a method of transferring your data without network connectivity by using an external storage device and physically transporting your data to its new storage data center. There are a few different tools offered by AWS to migrate data offline. The tool selected really depends on the amount of data you want to transport. The option includes Snowcone, AWS Snowball, AWS Snowball Edge, and Snowmobile. If you need a secure way of transporting under 8 terabytes of data, then you should select AWS Snowcone. AWS Snowball allows you to transfer terabytes to petabytes of data. It can be used to move a workload to AWS, or it could be used as temporary storage too. It is useful for large dataset transfers with limited network bandwidth or security concerns. AWS Snowball Edge provides the similar storage as AWS Snowball with additional computing capability on board. The additional computing capability would allow you to perform machine learning, data analytics, or data preprocessing on board. The option AWS Snowmobile is literally a 45-foot semi-truck. It allows you to transport exabyte scales of data. It solves the problem of large-scale data transfer that would incur networking costs and long transfer times. When determining if Snowball is a good option, you should first determine if the amount of data you're trying to migrate is too large for the network bandwidth you have available. If this is the case, you should check your infrastructure if you can support the Snowball device that you would order. Create a timeline for delivery, the timeline for data replication, and shipping. Set up a staging area to manage your migration, and then check the device availability in your region. You can order a single device or a group of devices to meet your need. The overhead involved in an offline data migration using Snowball involves the time to transfer the data, the power requirements for the data itself, the personnel needed to manage the migration, and the physical space requirement. Take a look at the summary of features of the AWS Snow services. This should hopefully help you determine which service you would select for offline data migration if necessary. Let's take a look at a simple diagram of what would happen if you are decommissioning a data center and want to migrate your data to the cloud. You would initially order your Snowball device through the AWS console, then use the Apps Hub graphic interface to manage your device once it arrives. When your data has been duplicated on the device, you should ship it back to AWS. The data on the device would be imported into an S3 bucket in your AWS account, and all this can be monitored in your AWS console. The option to manually synchronize your data from your on-premise data storage to an AWS account can be done using FTP or SFTP. But some system tuning should be done to see decent performance. System tuning options include testing the number of Amazon S3 concurrent threads, the file part size of a multi-part file upload, your TCP window size, and likely you want to run this in parallel. Do you want FTP support to S3 for those older legacy applications, or to just avoid a major application update? If for whatever reason you need to transfer your data over FTP or SFTP, the option is there using AWS Transfer Family Service. Data sync is recommended, but if data sync is not supported in your environment or legacy applications use FTP, then you might consider the AWS Transfer Family. Here we can see a flowchart of how the AWS Transfer Family works. First, you have to go to your AWS account and find the AWS Transfer Family service. From there, choose a protocol, server endpoint, and where your data is stored, such as S3 or EFS. Now, your existing user and application can continue using the same protocol to access or write out their data, requiring minimal change to your code. The main benefit of using the AWS Transfer Family is how easy it is to get started using a legacy file transfer protocol like FTP, plus how it seamlessly integrates with AWS services like S3 Storage Bucket for virtually limitless storage, and Amazon IAM Identity Access Management for control. This should also allow you to continue using any legacy application that requires FTP, SFTP, or FTPS. Migrating your data to AWS can be complex. You have to understand the security risk involved when moving your data from your on-premise data center to AWS. Then understanding when you're storing your data on AWS, most likely it will be across multiple accounts accessed by multiple users. Having some sort of standard of security to ensure that your data is being properly secured and encrypted if required. The complexities of AWS should be taken into account, and the proper training be given to the personnel that will be doing any migrations to AWS. Make sure they receive proper training and some hands-on experience before conducting any migrations. When scheduling your migration, be sure to consider any dependencies on the workload being migrated and any network bottlenecks might occur during the time of the migration window. Billing is another challenge when migrating to AWS. When you're doing a data migration, you should take into account the amount of data you're going to be transferring, the cost of moving the data into and out of AWS, and if you're using associated services such as a endpoint, direct connect, or a VPN, what are the fees associated with those services? To help you understand the pricing, use an AWS pricing calculator. Considering these challenges beforehand will allow you to save money, time, and any wasted effort. A server migration is the process of transferring data and services from one server to another. Performing a server migration quickly and effectively is critical to the success of your overall cloud migration. The most popular server migration strategy is to rehost. Rehosting provides a quick solution for a lift and shift migration to the cloud. It is also the initial step to later re-architecting or re-platforming of a service. The initial step to server migration is to identify the server or servers for migration, then place those servers into groups for a migration wave. Each wave should have a timeline for the final cutover date. The second step is to actually perform a server migration. This might require that an agent be installed on the server OS or host hypervisor to assist with the server replication. Then once the agent is installed, set up a scheduled time to replicate the server. Depending on the server storage space and your available bandwidth, this could be the most time-consuming portion of the server migration. Once the server replication is complete, the data replication should be verified. If the data transfer was successful, determine if you're now ready for testing the newly created replicated server on AWS. Step 4 is to deploy the newly replicated server on AWS. This will allow you to begin testing the functionality of any server or applications running on that replicated server. Rigorous testing should be performed to identify any unanticipated issues. Step 5 is the cutover step. Once testing has been completed successfully, you should create a newly replicated server with any updates from the source server. The update should verify the state of the data replicated for completeness. Now you're ready to cut over to the new instance. This might require a DNS change to redirect network traffic to your new EC2 instance. You should keep the old server active for a week or two as a fallback option. Testing is a critical part of any server migration. The test should be done at least 1 week before any planned migration cutover. During testing, you should at the very least test connectivity to the EC2 instance via SSH or RDP. Then perform any application acceptable testing to ensure functionality. Some tools available to perform a rehosting or lift and shift server migration are AWS Application Migration Service. This is the recommended tool for any small or large-scale migration. There is also AWS Server Migration Service, an agentless migration option, and Cloud Endure for any unsupported operating systems. Any of the AWS migration tools can be used over Direct Connect or a VPN connection. All data transfer are encrypted for security. For a successful server migration, it is important to train employees on the tools to perform the migration, then create and share the timeline for the server cutover. During the server replication, you should monitor and verify successful transfer as well as testing any services or applications running on the server. Finally, schedule a cutover time during non-peak hours using the AWS Application Migration Service or the AWS Server Migration Service. AWS Migration Hub can be used to assist in tracking the progress of server migrations. In some AWS regions, Migration Hubs directly integrate with AWS Application Migration Service or AWS Server Migration Service automatically. Together, these tools and services can help you migrate a server quickly and efficiently. A hybrid cloud environment is an IT infrastructure that mixes on-premise and cloud services. The hybrid cloud model allows you to deploy workloads into your on-premise environment or the public cloud depending on the demand on resources, a new project, or to reduce costs. It provides great flexibility by allowing more deployment options. The hybrid model has 4 broad use cases. Cloud bursting is an application deployment model where an application running primarily on-premise, but when the demand increases, AWS resources can be deployed to meet that demand. A hybrid model can include a backup and disaster scenario in which AWS stores critical data, normally kept on-premise, for emergency recovery. Distributing your IT infrastructure across the cloud and on-premise provides you really the best of both worlds. For example, by allowing you to keep low latency or sensitive data on-premise, then your company could migrate maybe business analytics with machine learning to the cloud. The option to offer geographic expansion could be too expensive for your company. If you need to bring your application closer to your end user for compliance and to reduce latency, use AWS Global Infrastructure. It will allow you to increase your infrastructure globally within minutes. When deploying a hybrid architecture model, it's important to keep operational consistency. This can be done by allowing the same set of interfaces and APIs to provision, monitor, and manage any resources, either on-premise or on AWS. You want to ensure that a hybrid model allows for easy management and using existing skill sets to maintain. Ideally, you want to keep the hybrid model consistent and agile no matter where your workload is being deployed, either on-premise or on the cloud. Tools to offer a hybrid model includes AWS Outposts, which allows you to run AWS infrastructure and services on-prem, such as Amazon EC2 or RDS databases. AWS local zones put AWS services near large populations to reduce latency to local users to milliseconds, where AWS Node devices collect and process data between your data center and AWS. Some options for containerization of application includes AWS ECS Anywhere that provides consistent tooling and APIs for container-based application orchestration. AWS EKS Anywhere also enables you to easily create and operate a Kubernetes cluster on-premise for easy management. AWS Outposts provides computing, storage, and database services locally. Outposts puts AWS hardware in your data center, which you can manage using the same APIs and management tools found on AWS. Outpost is available in a 42U rack that can be scaled from 1 rack to 96 racks to create a pool of compute and storage resources in your data center. VMware Cloud on AWS allows you to extend your current VMware infrastructure to AWS. You can maintain your VMware software-defined data center and gain direct access to native AWS services. This allows you to seamlessly integrate and extend your on-premise VMware environment to AWS with no re-architecting. AWS Application Migration Service, also known as AWS MGM, is a service that is provided by AWS that allows for a quick and easy lift and shift of a workload without any changes being required. AWS MGM service initiates block-level reads of any volume attached to the server and replicates it to EBS volumes attached to an EC2 instance on AWS. The block-level read is also continuous, meaning it can automatically continue from drop-off points. During the migration, a server conversion is launched to convert disks to boot and run on AWS, as well as inject drivers, make bootloader changes, and install cloud tools. AWS MGN is the recommended migration service when rehosting to AWS. MGN is the successor to Cloud Endure, with additional functionality and integration to other AWS services. A possible use case to revert back to Cloud Endure is if the AWS region you want to migrate your server to does not offer the AWS MGM service, or your workload operating system is not supported. There are many benefits to using a service like AWS MGM. It will allow you to minimize downtime and reduce the manual intensity of rehosting. By duplicating and reconfiguring a new server, allowing you to automatically rehost and create identical block-level replications of your current server. And all this can be done through a console-based GUI, including deployed test servers and ultimately scheduling the cutover. There are 5 stages to the AWS MGN lifecycle. The initial step is to create a replication setting template that will be used to deploy a lightweight instance to handle the cloning and synchronization of the on-premise workload to AWS. Step 2 is to install an agent on the server that you plan to migrate. This agent will allow connection between the on-premise workload and AWS. The next step is to replicate the application to the cloud, including any data and configurations. The 4th step in the migration process is testing to ensure the application is functioning completely. The last step is to perform a cutover in which you are switching the on-premise copy of the workload to the cloud-based copy. To get started using the AWS Application Migration Service, log into your AWS account and search for the service. You will come to this welcome page and click Get Started. The first thing you need to do is set up your replication template. The replication template initializes the service but also provides the settings for the replication server that sets up the connection between your on-premise data center and AWS. The connection could be done over a private IP address using a VPN or direct connect. Once you're happy with the template settings, you can click Create Template. To get started adding source servers to the application migration service, the replication agent or the agent needs to be installed. You can go ahead and download the agent from the URL in the documentation. Once the download has completed, run the installer. By doing sudo python 3 and then the file name, you should be able to run the agent installer. As part of the installation, you will be prompted with some setup questions. The questions will include information about the region, your access key or secret access key, the IAM user in your account you're using that has access to be able to run the AWS Application Migration Service, and any resources needed. Next, you'll be prompted to enter the disk information about which attached disk on the system you would like to replicate. Once you enter the disk path, go ahead and hit enter, and you will complete the installation of the agent on your source server. Once the agent has completed installing, you should now be able to go to your AWS account and go to the Application Migration Service and see the newly added source server listed. Depending on how much time has elapsed, the data replication status might be initialized or in the process of replicating. So depending on your network speed and the amount of data that needs to be replicated, this time will vary. So you should wait for your data replication to complete at this point. Once the replication has completed, a snapshot has been created of your source server. To get additional details on your source server, click on the hostname of the source server you see listed. This will bring up additional details such as the lifecycle and the stage of the lifecycle your replication is currently in. It currently is still creating the snapshot, so it is not in the ready state. Once the replication has completed, the lifecycle status will change to the ready for testing. At this point, you can launch a test instance. This can be done by clicking on the top test and cut over drop-down menu. Select Launch Test Instance. You will now enter the test and progress stage. If you click the job ID, you will get detailed information about the testing instance. During this stage, complete any testing you feel necessary of the snapshot taken of the source server. Once your testing has been completed, come back into the service and select Mark Ready for Cutover. Once you select this, the test instance is still running, so make sure the EC2 instance has been terminated if you do not wish to conduct any further testing. At this point, you should schedule an outage window when you're ready to do the final cutover. When you are ready for the cutover, come to the same drop-down menu and select Launch Cutover Instance. This will launch an EC2 instance in your account. If you take a look at your job log, it will list the instance ID numbers for the cutover and for any test instances launched. Once the cutover has been completed successfully and tested, you can go ahead and finalize the cutover. This will stop all data replication and cause all replicated data to be discarded. And the EC2 instance launch will now run the fully migrated service. Congratulations, you have successfully migrated a server. AWS Server Migration Service is an agentless server migration tool that makes it easy for you to migrate on-premise workloads running hypervisors such as VMware or Hyper-V, or on a cloud provider such as Microsoft Azure. SMS incrementally replicates your local VMs as Amazon Machine Images, AMIs, and then makes them ready for deployment. Some of the key features of AWS SMS is how it automates the migration from on-premise to AWS without any agent being installed. Instead, it uses an appliance that is deployed in your on-premise virtualization environment, and then the appliance is used to replicate your virtual machines to AWS. The benefit to using AWS SMS is how easy it is to get started for free. It requires minimal downtime to set up, and server replication can be scheduled to run in parallel. AWS MGN and Cloud Endure are very similar block-level replication services that use an installed agent. AWS MGM has integration with other AWS services such as Migration Hub and CloudWatch, which Cloud Endure does not. Both MGM and Cloud Endure allow for migration from physical, virtual, and cloud-based servers to AWS. Where AWS Server Migration Service does not require an agent, AWS Migration Service allows you to migrate on-premise virtual machines to AWS using a virtual appliance deployed in your VMware or Hyper-V environment. Here we can take a quick look at the AWS Server Migration Service lifecycle. In your on-premise data center or on Microsoft Azure Cloud, you will have a server migration connector. It will come as an OVA image to deploy. The connector will use an IAM user credential to communicate to AWS, where the AWS Server Migration Service will create snapshots that will be imported to AWS as an Amazon Machine Image. Once the AMI has been created, then an EC2 instance using the newly created AMI can be deployed. During deployment, you can configure your EC2 instance size, instance details such as VPC and subnet, and then the EC2 instance root volume will be based on the snapshot. Finally, you can launch a newly created replicated server. In your AWS account, go to the AWS Server Migration Server and click Get Started. Here you'll be able to download the Server Migration Connector. This is a virtual machine that could be imported into your virtualization environment in your on-premise data center. Once a virtual machine has been imported into Hyper-V or your VMware environment, go ahead and launch the virtual machine and then assign it a static IP address. This will allow you to access it through a local browser on your network. You can set up the environment through this web interface. At this point, you will be prompted to accept licensing and create a password. At this point in the setup, you will be prompted to perform the following steps on the virtual machine. The login information is EC2 for the username and EC2pass for the password. This will allow you command line access to perform the following steps. To help you with this, you can do a sudo setup.rb command. You can go ahead and click Next. Now select Next to select the default settings for logging and updating. At this point, you will need to provide AWS credentials to an IAM user with the right level of access. Now you get to choose your VM manager type, followed by providing a username and password to your company's Active Directory domain or a local admin. So I will be using the local administrator account, but in a larger network, you may choose to use a domain admin account. Go ahead and provide the credentials and the hostname information. You want to make sure to verify and trust and then click Next. Once you get it, congratulations, you're ready to go. If you go back to your AWS account, you should see one connector running. If you click on it, you should see a healthy status and some information about the server. Here you can see some status information about the service, but now if you're ready to import the server catalog, you can get a list of the virtual machines that are running in your virtualization environment. Then you can select the one and create a replication job. You will be asked about the type of job. If it's a continuous job or a single immediate replication, you can go ahead and select the options of encryption and permissions as well. When you're ready, click Next. This will go ahead and create the replication job. The job should start and it will give you details as the job is running. Depending on the amount of data you're transferring and the bandwidth you have available, the length of time for this replication can vary. As the job is running, you can go ahead and go in and check what progress your job has made. Once the job is complete, an Amazon machine image will be created with the content of your virtual machine from your data center. From the AMI, you can go ahead and launch an EC2 instance with the replicated data. Your current infrastructure might include a mix of virtual machines, physical servers, or some legacy systems running homegrown applications. It might not be an easy lift and shift situation. Some possible solutions are initially migrating services and workloads that are compatible. Then you can choose the option of running a hybrid environment where you align your AWS Cloud infrastructure with your on-premise environment to continue running these legacy systems till you're able to re-architect and decommission. During migration, there is always the possibility of losing data. It's important that you verify the integrity of your data once it has been migrated, and at a later point, during the cutover, you should duplicate any changes or the delta of the data to ensure that you have the latest version of your server before the cutover. This can be done by using the AWS migration tools that include data verification. The complexity of maintaining a cloud infrastructure and completing a migration to the cloud makes it hard finding individuals with the skill sets needed. The best long-term solution is training individuals in-house, since they are already familiar with your legacy systems. Your existing employees would be the best suited to assist the migration once they gain AWS skills. For mission-critical workloads, you will want to minimize any possible downtime or performance disturbance. For the migration of these workloads, you should do thorough testing and schedule the cutover during non-peak times. Data security and compliance is a top concern when considering a cloud migration. AWS provides many options for securing the data in transit and at rest during the migration process. It's important to read through the technical documentation to understand the exact encryption and compliance option for each service you plan to use. The time required for migration is a concern for everyone involved. The best way to understand how long it would take to replicate a server to AWS is by testing it first. The time it takes to replicate a server can vary greatly based on the time of day, the region selected, and the server performance. Long-term, your company should enjoy an increase in efficiency and a cost savings. But in the near term, you might feel it's a struggle to reach these savings. In every aspect of the migration, there are financial risks. The best solution to this concern is preparation and planning. Understanding the costs associated with a server or a group of server migration should be done before the migration occurs. Then by doing the migration in waves, you can analyze your financial investments before continuing on to the next migration wave. In your current on-premise infrastructure, you very likely have a database that will need to be migrated. AWS provides multiple types of databases, as well as services to automate data migration that will replicate the database and help perform schema conversions if required. AWS relational database services include Amazon RDS, which allows you to easily migrate to a managed database service that supports familiar database engines such as MySQL, MariaDB, PostgreSQL, Oracle Database, and SQL Server. The RDS service provides several instance types to help optimize performance. Amazon Aurora is a MySQL and PostgreSQL compatible database specifically built to be cloud native. Amazon Redshift is a managed petabyte-scale database warehouse service. AWS offers the option for NoSQL databases as well. For example, DynamoDB is a fully managed, fast, serverless, key-value NoSQL database designed to be cloud native. Amazon DocumentDB is a fully managed document database service that supports MongoDB workloads. Neptune is a fully managed graph database service that is used when working with application datasets that are highly connected. And lastly, Amazon Quantum Ledger is a managed ledger database that provides cryptographically verifiable transaction logs maintained by a central trusted authority. When migrating your database to the cloud, you shouldn't limit your options. This could be a great opportunity to update or modernize your database. This can be done by migrating to a cloud-native database with improved performance or select a database that is optimal for your workload. Just like migrating a server, you might consider doing a lift and shift of your database. Then at a later point, modernize your application. This provides a fast migration and time to properly modernize your database, which ideally result in improved performance and reduced costs and maintenance. Commonly, databases are tightly coupled with an application in your infrastructure. Database migration strategies generally involve some level of application change to use the newly migrated database. These changes can range from a simple change of a database endpoint to a complete code rewrite. Before any migration, determine the level of application dependencies to that database. The first part of a database migration is getting prepared. What are the workload dependencies between your application and the database you plan to migrate? You should also determine what level of complexity is involved in your database migration. Is it a simple migration or will it require re-architecting? Determining the complexity of the migration will allow you to understand the best migration strategy for your database. Is the database directly accessed by any other workloads in your data center? You should determine how a migration of the database would affect the application access and performance. Will network latency cause performance issues if migrated to AWS? Does your application also access any other databases or applications running in your data center? How would that affect your migration? Check for any hardware or network dependencies. Determine if your workload can be supported on AWS hardware before migrating your database. Try to address these hardware issues before continuing. Is there a bandwidth requirement that requires your workload to remain on-premise? Determine if there is an AWS service to help meet these requirements. Does your application require a specific database engine or does AWS support the same engine? To help you understand the complexity of your migration and determine your migration strategy, AWS offers a workload classification framework that you can access through AWS support. The AWS WQF categories will assess your migration workloads and place it in one of the 5 categories. The Category 1 application uses open database connectivity that allows for a simple migration with less than 50 manual changes required. Category 2 uses some lightweight proprietary features but no advanced SQL language. Category 3 uses advanced storage logic and data proprietary features. Category 4 would be an engine-specific workload that would require a specific framework that is only supported by a commercial database engine. A non-portable workload using a database engine that has no cloud equivalent will fall into Category 5. During this phase of migration, you should use the information gathered during the preparation phase and come up with a migration strategy. You can use the 7 R's of migration to help you develop a migration strategy. The option to rehost a database means moving the database to the cloud with no changes. An example of this can be an on-premise Oracle database moved to an Amazon EC2 instance. To relocate a database involves a hypervisor level lift and shift. This option is only available to customers using VMware Cloud on AWS. It entails migrating infrastructure to AWS without any hardware, application, or operating changes. For example, relocating the hypervisor hosting your Oracle database to VMware Cloud on AWS. To re-platform a database involves migrating the database to the cloud with some level of optimization to take advantage of some of the new cloud features. An example of this can be seen when migrating a MySQL database to Amazon RDS for MySQL. Depending on the situation, it might be best to repurchase a product to replace the traditional database. This could be using a software as a service product and then migrating your company data into the SaaS platform. This is a situation where if you have an on-premise customer relationship management application, but as a company decide to migrate to Salesforce. To refactor or re-architect a database would involve taking full advantage of cloud-native features with the goal of improving scalability and gain agility. This might involve rewriting your application to use features offered by the AWS services. This can be done in cases where you want to break up a monolithic application into microservices, and then each microservice could access their own database. Or migrating your relational database to Amazon DynamoDB to improve flexibility and performance. The last 2 R's in our migration strategies are retain and retire. Retain is to keep the database unchanged due to the amount of work that would be involved in a migration or no business justification for migrating. Lastly, retire is to decommission the database that are no longer required. It would be recommended to back up the data before decommissioning any databases. When selecting your migration path, you should see how the options selected would improve your infrastructure either by allowing for future growth, optimizing cost and performance, or allowing for speedy migration. The AWS recommended migration strategy according to the workload complexity can be seen here. The lesser complex workloads should be considered to be refactored to gain cloud-native improvements, whereas very specific engines workloads will probably need to be rehosted to migrate to AWS. To assist with some common database migration scenarios, AWS has published migration playbooks with step-by-step instructions. This includes migrations such as Microsoft SQL Server to Amazon Aurora or Oracle to Amazon Redshift. Once the database schema has been migrated using the tool Schema Conversion Tool if needed, you're ready to move your data from the source database to the target. The method you use to migrate your data depends on your application availability requirements. The data migration service can perform a one-time copy or continuous replication till you're ready to cut over to the new database. An offline database migration is an alternative option using DMS. You can do this by using a CSV file, a database dump, an ETL job, or an Oracle copy to Postgres SQL utility. Testing is a required part of database migrations. Functional testing should allow you to determine if your application is working correctly with the new database. When doing performance testing, there should be an acceptable response time. Testing can be done manually or automated. Depending on your environment, you might benefit from an automated testing framework. There are a few different database cutover strategies. The first one we'll look at is offline migration, which uses the AWS Database Migration Service full load task setting, but there are alternative offline migration options. During this migration, reads will be allowed on the source database, but write traffic will be stopped. Once the data has been duplicated, updates to the application should be done to point to the new database. An active database migration requires that the source and the target database allow write traffic during migration. This migration strategy can be challenging to set up, but provides flexibility in how long and when the migration can occur. Dual write operations or bilateral directional replication should be set up during active database migration. Over time, you should slowly redirect your workloads to the new database server till all traffic is directed at the new database. An incremental migration allows you to migrate to a new database in small sections by breaking up a monolithic application into microservices. Each microservice would have its own database or table that is not shared or accessed by any other part of the application. You can then migrate the microservices to the new database one by one using any cutover strategy you want. The new microservices would write to the new database, and the old part of the monolith that hasn't been migrated yet will continue to write to the old database. A flash cut migration relies on continuous data replication from the source database to the target. All read-write traffic will remain on the source database during the sync and verification of the data. Once all the data has been replicated, schedule an application outage. At that point, you will update your application to point to the new database and end the application outage. It's important to understand the differences of running a database in AWS versus on-premise. Depending on the database service being used, the management of the database can vary greatly. If you opt to rehost your database, your operational overhead is higher. This means you're responsible for tasks such as backups, scalability, and disaster recovery. If you did a database refactoring to a managed service, this will reduce some of the differentiated heavy lifting of running your database on AWS. Additionally, you would gain built-in performance tools such as Amazon RDS Insight to detect performance issues. No matter which migration strategy selected, Amazon CloudWatch can be used to collect and act on metrics data. This would include CPU utilization, memory usage, I/O performance, database connections, and more. CloudWatch also has the added benefit of acting on real-time metrics data. This could be, for example, initiating action when a given threshold is crossed. After the migration, it is the optimization phase where you try to maximize the benefits of hosting your database and application on the cloud. The optimizations areas to address include cost, performance, security, or disaster recovery. For example, auto-scaling can be added to your service by adding additional read replicas during peak business hours, while removing the additional database read replicas during off-peak hours to reduce cost. Recommended best practices for hosting a database on AWS includes monitoring memory, CPU utilization, and storage usage. Ensure that scaling is built into your database service. Automate backups and snapshots for any disaster recovery, as well as testing failover and recovery. Some additional best practices include setting a DNS time to live value of less than 30 seconds. The reason for this is during failover, the underlying IP address will need to update. Next is provisioning enough system memory where the active working set resides mostly in memory. This would improve overall performance of your database. Lastly, select an instance type for your database server that has optimized IOPS for improved I/O. To use the database migration service, we are going to have a destination database. So the first step is to create a database. I will be using the RDS service. I will create a standard database using a MySQL engine, and I'll be able to select which version I want. Once I select my version, I'll be able to select a template. I'll be using the free tier in this demonstration, but go ahead and check out the production and test dev templates as well. Each template will provide you a slightly different configuration for your instance and your availability. So now I'm going to go ahead and name my database instance and give it an identifier. Then provide some admin credentials to your database service. So by default, the username is admin. You can change that and go ahead and set an admin password. Since I'm using the free tier, the instance type is a ddT2.micro. That will change if one of the other templates were selected. For this demonstration, I'm not going to change the storage settings. We could always go ahead in there and allocate more storage or choose a different storage type that has faster I/O. In this next section, connectivity, you can select the VPC or subnet you would like your RDS database instance to be deployed to. You could also select if you want public access to your database or if you want to keep it on a private subnet. Next is selecting or creating a new security group. This will allow for the appropriate incoming traffic to be open to the RDS instance. We will leave the default port and also leave the default authentication method, but you can also use IAM and Kerberos authentication. Now we are ready to create our RDS database. Once the destination database has been deployed, we're going to go ahead and go over to the database migration service. The first step we're going to do is create a replication instance. This is essentially an EC2 instance that handles all the underlying automation in migrating your database from the source to the destination. Part of the replication instance configuration includes the name of the instance class, the engine version, the allocation storage, if it's publicly accessible. Now, depending on the database you're migrating to, you might select a more powerful instance class, as well as a larger amount of allocated storage. Once the configuration is done, go ahead and click Create. It will deploy your application instance. It will take a few minutes for your replication instance to become available. Once it is ready, now it's time to create endpoints. An endpoint provides connection information, data storage type, and location information about the source database and the target database. First, I'll create the target and point it to the RDS instance we just created. We should provide the endpoint identifier and the target engine. Now we're going to put in the credentials to access the database as well. Once the credentials have been entered, go ahead and create your endpoint. Now repeat the same steps again, but now for the source database. My source database is a MySQL server. I'll go ahead and provide the credentials required to log in by clicking Provide Access Information manually. Once you enter the required information, there is an optional test and point connection at the end to make sure your configuration is correct and you can access the database to perform the migration. Once the test is done, go ahead and create the endpoint. The last step is creating a database migration task. This is where all the work happens. You will specify the replication instance, the source database endpoint, the target database endpoint. You can also specify the table, engine, or schema to use for your migration, as well as any special processing or logging requirements. Once all this is done, you can go ahead and create your task. Once the task is done, you could run it immediately to begin the migration.